is forwarding. We tried the routing algorithm, the one we had, the link state mainly. And that was the main part of the lecture, how to understand link estates. So the algorithm should be basic, should be fun, should be easy. I'm going to do it today mainly, focusing on it. And I'll take an example. I'll choose one of the nodes, start from that as a source node, and I'll ask you to do the same diagram but from a different node as a source node. And we'll see how it works. And I'll ask you to do eventually the other parts of it. Last group asked me how many marks on this question. Last year we had a double check, it was 16. 3 parts. It was generous in my opinion. It's easy in my opinion. I think it's really hard. It just had 3 components, the actual diagram and the actual table. And then we had a short diagram how we got there in the focal table. And last year people asked me most of it and leave some part of it. So it's a matter of concentration. If you understand it, you should understand the full components. I'm not sure how many marks this year there is. I haven't done the questions already, but it might be a part of it. So any questions? Before I start, what's forwarding? Stacking. So what does that involve from incoming to outgoing exactly? Does that involve how many routers? 1, 2, 3, several?
Just one.
Just one. That's the main thing. Just rather one router. So if I'm forwarding, if I say forwarding, that means I'm forwarding a packet on the incoming link towards a router and the outgoing link. That's it. So usually a header file will contain a value inside that, whatever that value is, and therefore there is a table inside that router indicates what link should that go through. So let's assume there are 3 links here. Each one of them has an interface. Each interface are indicated by a number within that header file. So let's say 1 refers to link number 1, 1 0 refers to 2, 0 1 refers to 3, for example. That's it. So it's like an interface. The forwarding table will depend exactly on the header file, and then you know exactly where to forward that. So how is this different from routing?
Routing, like finding out how the packets go through the whole system through different routers all the way to the
Exactly. So it's just trying to route the actual packet towards the destination, and that might involve one router, or might get involved with numbers of hundreds of routers. So just imagine topology being like that. For example, so I want to send from here towards a destination, eventually reaching B. So the matter of this being involved with so many other routers, therefore you need to find a algorithm route to reaching the destination. The criteria of routing that packet depends on the routing algorithm criteria. So therefore, for the short link state that we had in our examples here, we are following the least cost path. And that number is indicated by either condition, number of users, bandwidth, so on. Well, you need to be concentrating on, if I want to go for a link state or Easter algorithm, I'm looking for the least cost path to reach my destination. Okay? So the main differences between forwarding and routing, one is involved with word router for simplicity, the other one is involved with the number of routers, i.e. the full route, the trip between the source and the destination. Is that clear? Any questions? Yes?
Who holds the information of how much a path costs? So path costs to them, who knows that?
Exactly. That's a very good question. So who knows that information? Anyone? The routers hold the information, but who decides these are the information are right or wrong? So who's the umbrella? Who's the higher umbrella then?
Service provider.
Sorry?
Internet service provider.
No, nothing to do with the service provider. What's that? What's that? The link state. What is it? It's an algorithm. It's a routing algorithm. So exactly, the routing algorithm eventually decides the forwarding tables and the values of these links. The links are associated with the bandwidth. So therefore, if you ask me, the question is exactly, why is this number 1, not 6, for example? This is not a real number within the routing algorithm. This is an indication of how heavy this link is used between those two entities. But who decides exactly the forwarding table and which route to go through, that depends on your routing algorithm. Hopefully that answers the question. because I was confused whether you are wondering who brings those numbers forward, or who exactly define which route you go and which number to follow. The people who the algorithm defines which route to follow. So if, for example, this is your route, the same route to reach the destination, but with different values. So which route do I take? Do I take this route or this route? The routing algorithm should decide where do you go, depending on your criteria. But the numbers are an indicator for how heavy this link is used. So there's no real numbers there, they're just indication eventually. They are like a usage table that indicates how heavy those are used. Just imagine that you have different physical links. So imagine this is connection, a fiber optic, and this is like a coax. Eventually the number should be different because of the speed that each one of them holds. So therefore, you might have a reliable service which requires heavily a reliable delivery, regardless of how fast we deliver. So even if this one, like have a 20, 21, while you're looking for reliability, you know, they also are very speedy, but you never know whether they are up or not. This route will be followed, depending on the result. Okay, let's jump to this. I'm going to do those. What I've done on purpose, I've gave high numbers on the links, because there's a lower chance of updating your table. And I've done that for a reason. I want you to understand purely what's happening here. And therefore, when I reduce the numbers into lower parts, therefore you can work on, because you understand the concept exactly. So I'm starting here from, so the question says, let's read the question. Consider the following network with an indicated link costs. Use the least cost path algorithm to compute the least cost path from X, now X is source node, to all network nodes, or no, to all nodes. Show how the algorithm worked by computing link state table. So what's the table? That's what we designed last time, and this is what we're going to do this at the moment. So how does the table look like? We'll start with a number of steps, the iteration of nodes, and you all end up destination with the values and the predecessor nodes. So this is how the table looks like. Steps, iteration of nodes, then you have the value of all destinations. You can put them in any order you want. My node, I'm beginning starting with X, therefore X should not be part of your destinations because it's a source node. Choose any node you want, put them in any order you want. So I'll starting with W, predecessor to W. I'll put V, predecessor to V. I'll put U. Well, I'm going higher than that, but that's U. Then we have Y, Z, T, they cover everything here? Z.
You got that?
Yeah. Should be done Z. That's 1, 2, 3, 4, 5, 6. Yeah, exactly. So let's start.
Are we doing it together? Are we doing it all
If you want to do it, yeah, by all means. I'll just do it. So first of all, X connection. So let's remind ourselves what is the rules. If I have a connection between two nodes, usually this is going to be a connection. For example, connection between X and Y. That's a connection between X and Y, and the value is 6. If I would say connection between X and Y and T, this is how you measure it, the connection between X and Y plus the connection between Y and T. So that's what? 6 plus 7. If there is no direct connection, I will indicate that we're all using one node, and therefore there's no connection in input. Let's jump straight forward to the question. So first one, X connection to W. Is there a direct connection? Yes, there is. Value is 6. Using a predecessor node is X. The first step, you're only indicating you have X, so you cannot use anything else. Your predecessor node will always be X. You trying to connect now V. What's the value? There's 3, and there is an X as a biggest limit. Then we're trying to connect to U. Is there a direct connection?
No.
What about Y?
Yes.
That's a 6 using X. Z, 8 using X. And finally T.
No.
Is that your first step? Any questions at the moment? What you do next, you bring the least cost path. That's node V. Yes, it's a V. Yes, that's V. So now you have 2 intermediate nodes. Oh, sorry, 1 intermediate. You have the source X plus your intermediate node V. So now you can use 2 nodes to get to your connection. If you get a least cost path, updated one, the least cost path will update the information and you measure the new connection of the intermediate node. If it's not being updated, just stick with the old number. Don't bring it to a higher number. So if I have a connection between X and Z is 8, and I have now Y, don't go to 6 plus 12 to 18, just for because it's a new connection. Stick with the old connection, because it's the least cost. Okay, so W. Is there a lower connection using V? So that's 3 plus 4. If I go through V, that will give me 7. 7 is higher, I'll stick with 6x. You see what I've done? Now I have V as an intermediate node, so therefore I can use V as a connection. So that's 3 plus 4, that's 7. If I'm trying to get to W, is that lower or higher? It's lower, it's higher, so I stick with that one. V, we already brought V down, we skip V. U,
Yes.
that will give me 6, using what?
V.
V. So now I've reached this stage where I've gone from X to V, that's a 3, plus another 3, V and U. I'm using V as my intermediate node or predecessor node, therefore I'll update my information as 6 using V. Y, if I go through V, that will give me 11. That's a 3 plus 8, therefore I stick with my old number, and that's 6x. Z, there's no connection if I go through V, so therefore it's 8x. And finally, we have T. Yes, I have a connection now. That's 3 plus 4, and that's 7 using V. How's that? I'm going through V. That's 3 plus 4, and 7 using V. Any questions? Step number 1. We do a ring down. Now we have 3 matching of 6 for W, V, and Y. Choose either one you want. I'm just going to do the first come, first serve. I'm going to use this one first. Choose either is fine. Step number 2. That will be now you nodes can use X with 2 intermediate nodes with V and W. This is your source, and those are your intermediate nodes. We already brought W down, we skip that. We already brought V down, we skip that. And now we have U. If I use W as well, can I have a lower path? So if I go through X to W, W to U, that will give me 9, and that's higher than the original. So therefore I'll stick with my original value, and that's 6 via V. What about Y? It's the same. If I cannot go through W, that will be longer, definitely higher. I'll stick with 6x.
Will it always be cheaper if it's directly connected?
No, if, for example, let's say this is 6, and those conditions are 1 and 2.
Oh.
So it's not cheaper, that will be 3. So
I mean, does that happen like?
yeah, that's fine. Let's, for example, this is heavily used by a number of users, this link. Or this link is actually a coax link. Meanwhile, this is a fiber optic and a fiber optic. Therefore, that's speed faster. So this number can indicate speed or usability condition. So, might be anything. Okay, what about Z? The same thing. If I go to W and V, we go back to X. That's not a reasonable way. So I'll stick with the same number, 8 and X. Finally, T. Again, if I go through W and and then I go to V, and that's still higher than the original one, so I'll stick with 7, and that's using V. Again, we have a matching of two numbers, they can be either or. I'll choose U. In this case, step number 3 will be X, V, W, and then we have U. I've already brought W down, V down, U down, then we have Y. If I use U as well, we have a lower connection, no, it's the same. I'll stick with 6, X, Z. I cannot get to it using other nodes, so therefore that will be 8X. And again, trying to get to T, even if I go through 3 plus 3 plus 2, that will give me 8. It's a higher number. So the better way is going 7 through V to get to T. So I'll stick with the same number. Nothing is changing. You can see it's sticking with the same old part. Now I choose the lower one, left with 6, X, so that's your Y. Step number 4 is X, V, W, U, and then we have Y. Skip those 4. Now with Z using Y, if I go through Y, that's X to Y 6 plus 12 to Z, that's 18. So I'll stick with 7. Oh, sorry, 8. Using X. Similar to T, if I go to Y to T, that's 6 plus 7, higher than 7. So I'll stick with 7, V. Which one is lower? Here is T. 5th step, X, V, W, U, Y, and now I have T. I'll skip this one, like I skipped the other ones. Do I have a lower connection to Z using T? No. That's 8X. Bring this one down, and eventually, finally, your least cost path will be X, V, W, U, Y, T, and Z. That's the first part of the question. Last year that was 10 marks. You just need 30 to pass.
Is it what, 90%?
Sorry?
What's the exam margin?
It's 100, but it's a 70% of the overall one. I mean, 30 to pass the exam.
40.
Yeah, well, so you don't need to pass the exam to pass the full. Because if you have 30% out of the coursework, you still pass. It's not passing components. You can pass either. It's not by components, it's by overall mark. Yes?
To use different numbers, such as use W, U,
Yeah.
I use different.
Yeah.
Will it be the same answer or the different?
It will be in the end, those will be, for example, swapped each other. Well, that's
Okay.
fine with me. I have
Okay.
the options available within my overall answer, so either way is fine. Any questions? The other part of the question says, draw the link state, the least cost path diagram. So what do? You follow the nodes that you chosen earlier are brought down. So this is how you do it. I'll just make a space in the middle here, and I'll draw the diagram that we want. So I'm starting with X. So we always start with X as a source node if I've been mentioned as a source node. What's the first node brought down? I've brought down V. So that's the first connection to you is V. How you construct your diagram? Exactly like that. So you skip that. So just put a mark here to indicate you've already done that. Second node you brought down, it was W. Look at W, that was a direct connection with X. So that's W. And then the third node you brought down is U using V constraint. So that's V fitting to U. Fourth node is Y using X. That's a direct connection to Y. Fifth node is T through V. So that's T. And finally, getting to Z using X. Was that clear to everyone?
How much is the diagram?
3. And the table 3. Again, that's what was last year. I'm not sure how much I'm going to do this year. Just don't take that as a definitive answer of this year as well. You need to change styles. Final thing is your forwarding table for X. So I'm saying your forwarding table for X, what is it? Usually I need to have the link and the destination. So that's your destination. That's your link. So you put all the destinations in the column of destinations, and that is Z, Y, W, V, U, and T. Put them in any order you want. Again, there's no order. So how do I get to Z? If I want to say the forward table, that's X, Z. Forwarding table for X to reach Y, that's X, Y. To get to W, that's X, W. To get to V, that's X, V. To get to U, X, V. No, you don't need to measure the third one. You just need to know the direct connection to reach the destination. That's X, V only. So you just say X, V. So
Then how come you need to do it once?
it's a forwarding. That's what's the forwarding? Attend to the finger. Forwarding is just to pass on from one router. You don't. This will know the forwarding to VU will be VU, but for X you only consider VV. The V will post it to U. Finally, to T again the same thing. X. V.
But then don't you need the other ones because if you know that it's going to
Yes, you need a forwarding table for each one of those. Each one of them will do their job. But for you, as an X, you are X. Your only consideration is to pass it to the next hop.
Yeah.
You don't care what will V do eventually. Well, you know U is connected to V, depending on your routing algorithm, which link state provide that. Sorry? That's the table purely for just words.
You will be.
You have a different table, which I'm going to do in a minute. Now, I'm going to ask you to do a table for, choose either one node you want. Let's say
T.
T? Okay, go for it.
Right, this is good.
So now you're starting from T to all of the nodes. Do the actual table, the diagram of the least cost path, and then the forwarding table for T. So everything I've done.
So then the T1.
Sorry?
Then the T1. Start from T.
Yeah, you start from T.
Yeah.
So now T, and then you change everything to everything else.
Oh, so
now T will be here and X will be here.
Oh, okay.
Going the same order. No, you're only saying one, you're saying which one and then the other you have to worry about.
This is a forwarding table for X.
What about, are you doing Y? No. You're doing V. Are you only doing yeah.
That's why that was. No, it's fine. Good reading as the letter.
Yes.
So now you can have two.
Yeah. Anything on the side. Alright, so that's the example. If you get something then that's it. It's because of why is that?
Yeah, it's still like, yeah, you just
The cheapest one is to you. Oh, no, it goes to you. Yeah.
I can see exactly
Don't put the source. Just the stage.
Question one.
Why?
I told you so.
Fun.
Then I just go back to the class. Right, I finished myself out. I did try once, and then I persisted, but I was doing it the right way around.
Okay, so we start. Finish. Okay, so tell me the first. What's the direct connection between? Now, I changed the table because I had X one of my destination. I had T one of my destination, but now we have T as a source node. So I've updated it. You will not have that issue in the exam because you're doing it for once only, so therefore you just don't update the tables. Just for the reason I'm showing that your table should have all your destinations, your source, you choose everyone. Okay, so what do we do? So first T connection to W. Is there a direct connection?
No.
It's the same as this. It's the same as this with X there.
V. U. Y. I'm not checking. Z. X. You should have all the same thing.
Was that 17 on white?
Right? 7T. You just have T at the moment. You can't use anything. It's the same?
You take you. And
So yeah, which one do you choose? You choose the least cost one. In this case is this one. And that's U. So the second step will be now is T and U. So now you have two nodes to connect. That's your first intermediate node. So to W, is there a connection and what's the value? Using
you
V.
stood.
If you go through U, that's 2 plus 3 plus 5. So I'll say that's 4 using T. Now we skip U, we've already brought it down. What about Y?
It's 12.
1 plus 12, you cannot get to. Be careful.
Oh, yes.
So you just, when the numbers are lower, you will find
No,
an
I
issue.
misread
So
BP.
yeah, just be careful, that's all. So Y would be the same as 7T. What about Z? Do you get there?
Nope.
I'm sorry, Z. What about X?
Tongue.
Okay. What was the next one now?
Tongue.
Exactly.
That's W.
Is it? Sorry. Trying to keep busy myself. So now it's V. 2 as T, U, so W. What's the value? 2 plus 3 or 4 plus 4
Five is
is
still
the
the
same.
smallest.
So that's 5 using U. What about V? You skip V because I already wrote that down. Now we have Y. Do you have a lower connection to Y? I skipped U because I already wrote it down. So do I have a lower connection to Y? No. That's 17. Z, do I have a connection to it?
It's 19. Oh no, sorry, yeah, I'm pointing.
Again, yeah. So X,
Yes. 5
so now you have V, so why not?
7.
So either you go 2, 3 plus 3 or 7.
down.
Using what?
Using big
What you bring down?
I think you just recommend using
3 will be T, U, V, W. Skip that, skip that, skip that. What about Y? Do you have a lower value? No, that's 17. 17. And then we have Z. Do you have a connection to Z?
No.
What about X? lower body or is this the same? So we have it now matching. We bring the first one down. So that's y. So that's 4 t u v w and then y. We skip those and brought them down. Do you have connection to z now?
Yes.
7 plus 12, 19. What? Using what? Y. Finally, x. You have a lower body to x. That's 7v. What do you bring down? Clearly you bring x. And therefore you have part t, u, v, w, y, and x. Yes?
Can you know 15x using no, sorry.
15x is 7. Why do you go to 15?
No, because if you go from t, v, x, and z.
You don't have x.
you
Now
don't-
you have x.
Oh, now we have.
Now you have x. Is that right? Now we can do that. T, 7 plus 6 plus
Yeah.
8. How much is that? Now we have a lower value.
Yeah. I did wrong.
Using what?
Using x.
X. That's the final node to bring down. And finally, lower back will be T, U, V, W, Y, X, and Z. Any questions? Okay, should be fine. Let's draw the tree. The least close tree, starting from T. So I'm starting from this side. First node you brought down, what was it? Was it
U.
U? Yeah. So that's what's the value? No, just one. Sorry, but you don't care about the value.
Three.
That's easy.
Three.
What's the third node? That's V using. So that's T to V. Big space here. Third node down. W using U. So that's W. Fourth one, that's Y using T. Fifth, to X using V. And finally to Z using X. That's it. I don't care about the shape. My main thing is you do the right connections. So if you put it down, up, I don't care. The main thing is just how is the right connections or not. So finally, I want your folding table for T. So if I say folding table, for T, you have the link, destination, sort all the destination, W, X, Y, Z, V, U. Okay? First link, T to W, that's TU. T to X, TV. T to M, to Y, TY to Z, CV to V, to U.
What bit isn't TV direct connections?
Sorry? No?
It's TV, TV.
That's V.
You said.
That's TU, yes, TU.
No, not above, you said TV.
It is, that's V. Don't be that crazy.
I swear you said TV.
Yeah, they should have
So, any questions? Is it clear to everyone? Should be straightforward, isn't it? Yeah, because you cannot get to Z unless you go that far. You just need the next hole. So, now we've done with the tutorial. I just want to highlight something. I think the final week is in week 11, isn't it? So that's 3 weeks left. I'm going to finish next week IP subnets, not the full addressing part. I'm just going to describe something called ARP, Address Resolution Protocol, where I associate between MAC addresses and IP addresses and why they are important together. And the next lecture afterwards, maybe I'll do class interdomain, classless interdomain routing. Now, I think some of you have already taken that, where you have, if that's your IP address, you need to mask something without a classless. So therefore, you have a number here, which indicates your CIDR. I think some of you have already taken that, so I'm doing that sometimes. So that'll be easy for you guys who've already done it. And I'll give you the coursework in week 10, explain exactly what is it. And eventually week 11 will be, I'll do socketing because I want to do the programming part of it. If you have any questions, please ask them.